In these examples, we'll see orthogonal set in R3. The first example is trivial. Basically, it is columns of the unit vector with ones only at one position in each column, and therefore immediately we can see that they are orthogonal. Any of these u1, u2, and u3, when we are dotting against each other, will produce the scalar 0. The second example, basically just interchange column 2 to column 3 from the first example, and again they are also an orthogonal set. Here, if we think of this set of P is equals to 3, that means we have 3 column vectors for the R3 space, then we can call this a basis because we have a linearly independent set of vectors that spans the R3 space. So these are bases, and in addition to being simply bases, they are also orthogonal bases. What about the third example? In this example, the column vectors are still R3, but we only have P equals to 2 of the, Therefore, using only U1 and U2, we can only span a subspace of R3. In fact, we are spanning a plane of R3. And hence, although they do not span the entire R3 space, they are still a basis of a subspace of R3. In the last example, you can figure out for yourself that U1 dotting with U2 is orthogonal, U1 dotting with U3 is also orthogonal, and all combinations of Ui dotting with Uj, I not equals to j, is equals to 0 in this example. What is a quick and easy way to find whether we have an orthogonal set? The idea is simple. You put the vectors you are given, for example u1 and u2, as column vectors in a matrix. So now we have a 3 by 2 matrix for S. S is a 3 by 2 matrix. There are column vectors showing us u1 and u2. We transpose S to get S of transpose. Basically, we are rotating the vectors from the column to become a row. And here we have now S transpose is a 2 by 3. What we then do is to multiply S transpose S. So we are having a 2 by 3 matrix multiplying by a 3 by 2 matrix. And basically, we are performing rows of U1 dotting with columns of U1 to give us the norm values of U1. And finally, we continue with the rest, and we'll get all the entries of a 2 by 2 matrix. It is the diagonal that we are interested in. The diagonal will tell us where the norm square, and the off diagonals will tell us whether the vectors are orthogonal with each other or not. If the vectors are orthogonal with each other, all the off diagonal would have values 0, as shown in the above.